How does wet bulb temperature affect HVAC systems? Imagine trying to cool a room on a hot, humid day. The way your air conditioning works depends a lot on the moisture in the air. That moisture level is measured by the wet bulb temperature. It's a key factor in how well HVAC systems perform because it shows how much evaporation can happen in the air. When you measure wet bulb temperature, you use a thermometer covered with a wet wick exposed to airflow. The temperature it reads is the lowest the air can be cooled through evaporation under current conditions. In systems that use evaporative cooling, like cooling towers or swamp coolers, the wet bulb temperature sets the limit for how much cooling is possible. When the wet bulb temperature is high, the air is already humid and close to saturation. This means evaporation is limited, and the system can't cool the air as much as it could in drier conditions. On the other hand, if the wet bulb temperature is low, the air is drier, and evaporative cooling becomes more effective. This allows HVAC systems to cool more efficiently and save energy. Designing HVAC systems involves considering the maximum expected wet bulb temperature for a location. For example, cooling towers are rated to work well at a standard wet bulb temperature of about 78 degrees Fahrenheit. If the actual wet bulb temperature goes above that, the system's cooling capacity drops because it can't cool water or air below the wet bulb temperature. This is why understanding local climate data is so important for system design and operation. Wet bulb temperature also impacts human comfort and safety. When it's high, the body's natural cooling process, sweating and evaporation, becomes less effective. This increases the risk of heat-related illnesses. HVAC systems need to keep indoor wet bulb temperatures within safe and comfortable ranges to prevent health issues and ensure comfort. In psychrometrics, the difference between dry bulb temperature, which is the actual air temperature, and wet bulb temperature tells us about the humidity level. A small difference indicates high humidity and limited evaporative cooling potential. A larger difference shows drier air, which means better cooling potential. This helps HVAC engineers choose the right cooling methods for different climates. In hot and dry areas where the difference between dry bulb and wet bulb temperatures is large, evaporative coolers work very well. But in humid climates with high wet bulb temperatures, traditional refrigeration-based air conditioning is necessary because evaporative cooling becomes less effective. To sum up, wet bulb temperature influences how well HVAC systems can cool the air, how much energy they use, and how they are designed. It defines the limits of evaporative cooling and affects indoor comfort and safety. Knowing and using wet bulb temperature data helps engineers optimize HVAC performance and keep environments safe and comfortable, no matter the weather outside.